Alright, so for this lesson we're going to talk about how to solve quadratic equations by factoring. So a couple of things. How do we know we have a quadratic equation to begin with? Well, that's because we have a squared term. We see that there's a variable squared. Alright, so by factoring we're going to have to utilize two things that we've done in previous lessons. And that is our factoring, of course. Whether you do that by grouping or the box method, I'm going to mix it up between those two processes just so everyone can see what it looks like based on which method they prefer. And then we also need to use the zero product property, which was your last assignment, right? That's where when we had two things multiplied to give us 0, one of those things had to be 0. So factoring is our first step, and then the zero product property is our second step. So I have 6 examples to go over here for your assignment to give you an idea of a bunch of just different variations of the problem so that you're prepared for different situations. Alright, so our first one, we have n squared plus 3n minus 40 equals 0. So you always want to make sure that it's equal to 0 because that's part of the zero product property. If it's not equal to 0, then we can't apply the zero product property. So now we're going to factor this left-hand side. So we have a 1 in front of the n squared. So 1 times negative 40 is negative 40. And we need to think of factors of negative 40 that are going to add to a positive 3. So 1, 40, 2 and 20, 4 and 10, 5 and 8. But it has to multiply by a negative, but add to a positive. So since it adds to a positive, the larger number needs to be positive. So the smaller numbers are negative. So in our list, negative 5 and 8 will add to 3. So if I'm doing this by grouping, looks like this. Right, we split up the 3n to be the negative 5n plus 8n. Now, grouping. So we can take out an n, we have n minus 5, and we can take out a positive 8. So we get n plus 8 times n minus 5. Now that's just the factoring. Now we're ready for the second part, the zero product property, actually finding the value of n. So we set each factor equal to 0. N plus 8 equals 0, and n minus 5 equals 0, and we solve. So for number 1, we get n is equal to negative 8, or n is equal to 5. Alright, so let's look at number 2. Number 2 looks very similar to number 1. The only difference is we have a 5 in front instead of a 1. So we start with 5 times 3, which is 15. So we need factors that multiply to positive 15, but they need to add to positive 8. Well, that's pretty simple, 3 and 5. So I'll factor this one using the box method. 5n squared and our 3. Now we'll put our 3n and our 5n. Alright, so 5n, have an n, left with 1 and 3. So we have 5n plus 3 times n plus 1 equals 0. So we factored now for the zero product property. set each factor equal to 0. Alright, so in this first equation, we're subtracting 3, but then we also have to divide by 5. So we get n equals negative 3/5, and n equals negative 1. Alright, so as you can see from these two examples, it's pretty much what you've been working on. Alright, let's look at example 3. So on example 3, there's one thing that has changed. We have a 7 on the right side. Remember, we need it to be equal to 0. So our first step is going to be moving the 7 over by subtracting. So negative 385 minus 7 is going to give us negative 392 equals 0. Alright, 392 is quite a large number. So we have 7, 7, and 392. So my mind tells me to check and see if 392 is divisible by 7, and it is. So what we'll do is we'll take out the GCF of 7 from all three terms. That is 56. So you could have factored without taking out the GCF, but now you're going to, or at that point you would deal with very large numbers. So I always try to see if I can factor out a value to make my number smaller and easier to work with. Alright, so now we need to factor what's in the parentheses. So we have a squared minus a minus 56. So we need to come up with the two values that are going to do multiply to 1 times negative 56, which is negative 56, and I need to add to negative 1. Well, that's going to be negative 8 and 7. So we'll have negative 8a and a positive 7a. And now we do our grouping. So we have a, we'll be left with a minus 8. We can take out a 7, we'll be left with a minus 8. So altogether, we have the a plus 7 and the a minus 8. But don't forget that 7 that we took out at the very beginning. So now that it's factored, we set each factor equal to 0. Now 7 is a factor, but 7 doesn't equal 0. So we can't do anything with that. So we take the a plus 7, set it equal to 0, and the a minus 8, and set it equal to 0. So we get a equals negative 7, and a equals positive 8. Alright, so number 4, very similar. We need to move the negative 2. So 3x squared plus 8x. Now we're going to add 2. So negative 18 plus 2 gives us negative 16. Alright, so let's see. Are 3, 8, and negative 16, do they have a common factor? No, they don't. So I'm going to have to work with 3 and the negative 16. So 3 times negative 16, that is negative 48. So factors of negative 48 that add to 8. Let's see. 1 and 48, 2 and 24, 3 and 16, 4 and 12. No, 4 and 12 will work. So it's going to be a negative 4 and a positive 12 because it needs to add to positive 8. So I'll do this one with the box method. 3x squared and our negative 16. Then we'll put our two factors in, negative 4x, and that is a positive 12x. All right, so we can take out 3x there, left with x and 4 and a negative 4. So we have 3x minus 4 times x plus 4 equals 0. Now set each factor equal to 0. So 3x equals 4, then we'll divide by 3, and x equals negative 4. So x is negative 4, or x is 4/3. Alright, so for these last two problems, they're still quite similar to what we've been doing, but notice it's not just a number on one side. We have variables on both sides. So you have some options. You can move everything to the right or everything to the left. The way that I decide this is I look at the squared term. And I make it to where my square term is always going to be positive. So in number 5, there are no squared terms on the right side. So if I move everything over to the left, my squared term remains positive. There'll be a positive 3n and a negative 28. Now remember to write it in order. Your squared term, the linear term, the one that just has the variable to the first power, and then the constant. In number 6, you can either move the 3n squared over or the 27n squared. Well, if we move the 27n squared over, it'll create a negative situation. So that's how I decide to move the 3n squared. But I also have to move the n. So 27n squared minus 3n squared gives us 24n squared. And 34n minus n gives us 33n. And then we have the positive 9. Now both of these problems look like the first two that we've done. So we'll factor and solve from there. So I'm looking for values that multiply to negative 28 but add to 3. So that would be a 7 and negative 4. So n plus 7 equals 0 and n minus 4 equals 0. So we get n equals negative 7 and n equals 4. Again, you can do grouping or the box method to get to the factored form. Now in the last one, we have 24, 33, and 9. What is the GCF of those three numbers? 3. So we can at least factor out 3 to make our numbers smaller and easier to work with. So now we have numbers like 8, 11, and 3. So 8 times 3 is 24. We need factors of 24 that are going to add to positive 11. Well, that's going to be 8 and 3. So I'm going to do grouping here. So we have the 3 from outside, 8n plus 3, and n plus 1. Then set our factors equal to 0. And solve.